Thanks, Brandy and OES for inviting me to this panel today. I'm really inspired by my fellow panelists and excited to share my journey with you all. I'm an early career professor at Singapore University of Technology and Design. My journey started in India, where I was born and brought up, and I did my undergraduate studies. My journey in field robotics specifically started in Canada, where I pursued my master's and PhD degrees. Um, During my PhD, I was fortunate enough to be working in a lab where they were building underwater and surface marine vehicles. Um, and here I got interested in research domain of multi-robot coordination, search, and planning. Specifically in applications of coral reef monitoring and search and rescue applications in marine domain. After my PhD, I applied for a postdoctoral fellowship under Singapore MIT Alliance for Research and Technology, where I was fortunate enough to lead the lab of researchers for developing mobility on demand systems, specifically developing applications for self-driving car. And now, as an assistant professor, I continue to work in these domains and build autonomy and algorithms for multi-robot coordination and do the planning under uncertainty sort of research in there. So today I would like to share one specific project, which is about coral reef monitoring. And I am sharing this project specifically because it beautifully highlights the interdisciplinary nature of field robotics. Here we were not only developing heterogeneous robots which could fly, be on the surface, and as well as swim underwater. But we were also developing an interdisciplinary team of students, researchers from as diverse field as marine biologists to electrical engineers, electronic engineers, hardware engineers, and software computer science engineers. This project brought us together to sort of seamlessly develop a front end for coral reef monitoring. But along the process, I learned a lot, not just by this particular application, but field robotics or field trials in general, that we need to practice a lot before we go out in the field. Especially in the case where some of these field trials are really expensive or risky at the same time, and you might not get enough instances to do that. So practicing before you get out on the field was very important, and it would bring diverse set of skills from various individuals together to make things happen. Another way I learned a lot, or like another way to have an early start in marine robotics field, if that's something of interesting to you, is to participate in competitions that allow you to get started. This is the video footage from Singapore Autonomous Underwater Vehicle Challenge, where students get to design, develop, and deploy their underwater vehicles and sort of compete not only locally but also at an international level. So if you get an opportunity to participate in challenges like this, I would highly recommend that. Some of my lessons from marine robotics research is make sure you do your logistics very well, because even a single nut or bolt missed out in the field can become quite expensive and might jeopardize your field trial. Make sure your platforms that you want to deploy are easily deployable without much of external help. Another thing which is very critical is real-time feedback. When you're deploying these field robots in a large scale, it's very important to sort of have a health check on them through real-time feedback. And make sure you have user-friendly designs, because we have several instances where we deployed our robot after 20 minutes of dive to just realize that we have actually not started the code that we wanted to do. And a user-friendly design would really help to reprogram on the go. Lastly, I would like to emphasize on the very important and a most critical part is the multidisciplinary team, which can help you not only technically, but also support you morally. So during your grad school, if you are like me, you might have lows and highs. And during my lows, I went back to something I call creative vents. This is where you can sort of regain your energy and then come back to your research with a fresh perspective. And for me, that was outreach initiatives. I was very actively involved in Women in Engineering initiatives at McGill through, say, like one of these events, which you can see here is a 3D printing workshop. We also did events for high school students to introduce them to STEM field, and this allowed us to mentor them and train them. So I'm not only grateful to my own mentors at McGill, but also the students that I got to mentor, because they taught me lessons and I learned a lot both ways. I would like to emphasize on this fact that something that really helped me was to build a support structure, and this support structure not only was my family and friends, but also it went beyond that. And when I could build connections with the community at large, I found a lot of strength in that. Some of my own lessons learned is that I would like to share with you, and I would like to leave this as my last slide, is to know yourself, know your strengths and weaknesses, follow your heart, because your heart will take you through your strengths, get your hands dirty early, grab the opportunities that come along the way, and make sure you have these creative vents to bounce back and bring the work-life balance that you are seeking for. And with that, I would like to thank everyone who was involved in my journey and helped me reach where I am today. And with that, I would like to take any questions that you might have during the end of the session. Thank you so much for your attention and time.